Ever wondered how to get the most out of your harvesting machines? Hold on! In this video we're going to tell you the different types of harvesters and the secrets to maximizing their performance. Harvesters work hard, but are they working smart? Or is your harvester leaving money on the field? To know what's the reason behind low yield and more waste, because in today's video we're going to tell you about the every harvester and how you can test them to increase their efficiency. Number 1 is Grain Combines Kings of the Cornfield. This multitasking marvel cuts, threshes and separates grain from chaff in one smooth operation. We measure efficiency for combined hinges on two key factors: speed and loss. We want the combine to race across the field, harvesting as much grain as possible while leaving minimal precious kernels behind. Testing involves running the combine through a designated test field. Sensors track its speed and gather data on grain yield. Adjustments are then made by tweaking of the cutting height or cleaning sieve settings to find the sweet spot between speed and minimal grain loss. Tree harvesters, masters of the woods. These powerful machines fell trees, delimb them and cut them to desired lengths. Efficiency for tree harvesters is a three-pronged attack: felling speed, minimal tree damage and clean cuts. In testing, we set up a course in a designated forest area with similar tree types. The harvester tackles the course with data collected on felling time, number of cuts needed per tree. More cuts is equal to less efficiency, and any damage caused to surrounding trees. Adjustments are then made to the harvester's cutting head and processing unit to optimize speed, minimize cuts and ensure clean cuts. Sugarcane harvesters, sweet success on wheels. Sugarcane harvesting demands a delicate touch. These specialized machines maneuver through sugarcane fields, cutting and chopping the tall stalks without damaging the precious sugar content. Its efficiency focuses on maximizing the amount of harvestable cane while minimizing waste, tops and leaves left behind, and juice loss. In testing, we run the harvester through a designated sugarcane plot. Data is collected on the amount of cane harvested, the percentage of juice extracted, higher is better, and the amount of leftover plant material. Adjustments are made to the harvester's cutting blades and conveyor speeds to ensure a clean cut, efficient processing, and minimal juice loss. Potato harvesters, unearthing efficiency. Potato harvesters carefully dig up the precious tubers, separating them from the soil without causing bruises or damage. Efficiency for potato harvesters revolves around maximizing potato yield while minimizing damage. Testing involves running the harvester through a designated potato plot. Sensors track the amount of potatoes harvested and any damage caused during the digging and separation process. Adjustments are made to the harvester's digging tines and conveyor belts to ensure a smooth and efficient operation that preserves the quality of the potatoes. Forage harvesters, chopping up efficiency. Forage harvesters, also known as chopper harvesters, play a vital role in livestock farming. They chop up crops like corn, alfalfa, and hay for animal feed. Here, efficiency is all about maximizing the amount of chopped forage while minimizing processing time and fuel consumption. Testing involves running the harvester through a designated field with the target crop. Data is collected on the amount of forage harvested, processing speed, tons per hour, and fuel consumption. Adjustments are made to the harvester's cutting blades, feed rate, and engine settings to find the perfect balance between processing speed, fuel efficiency, and optimal chop size for the specific forage. Cotton pickers, from field to fabric. Cotton pickers navigate cotton fields, separating the fluffy bolls from the plant with minimal damage or loss. Here, efficiency is about maximizing the amount of high-quality cotton collected while minimizing trash, leaves, stems, and fiber loss. Testing involves running the picker through a designated cotton plot. Data is collected on the amount of cotton harvested, the percentage of clean fiber, higher is better, and the amount of unwanted plant material. Adjustments are made to the picker's spindles and suction settings to ensure a gentle yet thorough harvest that preserves fiber quality. Nut harvesters, cracking the code on efficiency. Nut harvesters tackle the delicate task of collecting nuts like almonds, walnuts, and pecans. These machines shake the trees, causing the nuts to fall onto a catching mechanism. Efficiency focuses on maximizing nut yield while minimizing damage to the trees and the nuts themselves. Testing involves setting up a course in a designated orchard with mature nut trees. The harvester tackles the course with data collected on the amount of nuts harvested, the percentage of undamaged nuts, and any damage caused to the trees. Adjustments are made to the harvester's shaking intensity and catching mechanism to ensure efficient collection without harming the trees or the precious nuts. Olive harvesters, a high-stakes harvest. Olive harvesting demands a careful touch to preserve the delicate fruit used for prized olive oil. Olive harvesters come in various forms, from mechanical shakers to trunk shakers that vibrate the olive tree. Efficiency revolves around maximizing olive yield while minimizing fruit damage and loss. Testing involves setting up a course in a designated olive grove. The harvester tackles the course with data collected on the amount of olives harvested, the percentage of undamaged olives, and any damage caused to the trees. Adjustments are made to the harvester's shaking intensity or combing mechanisms to ensure a gentle yet efficient harvest that preserves the quality of the olives. Grape harvesters, preserving the essence of wine. Grape harvesters navigate vineyards, carefully picking or shaking grapes for wine production. Here, efficiency focuses on maximizing the amount of high-quality grapes collected while minimizing damage and unwanted plant material. Testing involves running the harvester through a designated vineyard section. Data is collected on the amount of grapes harvested, the percentage of undamaged and ripe grapes, ideal for winemaking, and the amount of leaves and stems present. Adjustments are made to the harvester's picking mechanisms or shaking intensity to ensure a gentle and selective harvest that preserves the quality of the grapes for premium wine production. Mushroom harvesters, cultivating peak efficiency. Mushroom harvesting can be a tedious task. Mushroom harvesters, specialized machines designed for efficient collection in commercial mushroom farms. These machines typically use a combination of cutting blades and conveyor belts to harvest mature mushrooms. Efficiency revolves around maximizing the yield of high-quality mushrooms while minimizing damage and ensuring optimal freshness. Testing involves running the harvester through a designated section of the mushroom farm. Data is collected on the amount of mushrooms harvested, the percentage of undamaged and marketable mushrooms, and any bruising or damage caused during the process. Adjustments are made to the harvester's cutting blades and conveyor speed to find the perfect balance between speed, efficiency, and preserving the delicate mushrooms. Blueberry harvesters, delicate treasures, maximum efficiency. Blueberry harvesting requires a gentle touch to avoid damaging these delicate fruits. Blueberry harvesters utilize various mechanisms like combs or shakers to gently detach the ripe berries from the bushes. Here, efficiency is about maximizing the yield of high-quality blueberries while minimizing damage and fruit loss. Testing involves running the harvester through a designated blueberry patch. Data is collected on the amount of blueberries harvested, the percentage of undamaged and ripe berries, and any crushed or damaged fruit. Adjustments are made to the harvester's combing or shaking intensity and catching mechanisms to ensure a gentle yet efficient harvest that preserves the quality of the blueberries for consumers. Cocoa harvesters, unveiling the secrets of chocolate. Cocoa pod harvesting requires precision to ensure the quality of chocolate production. These specialized machines navigate cocoa plantations, selectively harvesting ripe pods without damaging the trees or immature fruit. Efficiency focuses on maximizing the yield of high-quality, ripe cocoa pods while minimizing damage and waste. Testing involves running the harvester through a designated section of the cocoa plantation. Data is collected on the number of pods harvested, the percentage of ripe and undamaged pods, and any damage caused to the trees or immature pods. Adjustments are made to the harvester's cutting mechanisms or picking arms to ensure a selective harvest that preserves the quality of the cocoa pods for delicious chocolate. Seaweed harvesters, cultivating efficiency from the ocean. Seaweed, a valuable resource with various applications, requires specialized harvesting techniques. Seaweed harvesters come in various forms, from underwater cutting machines to surface-based collection vessels. Here, efficiency revolves around maximizing the amount of high-quality seaweed harvested while minimizing environmental impact and maintaining sustainable practices. Testing involves running the harvester through a designated seaweed bed. Data is collected on the amount and type of seaweed harvested, the health of the remaining seaweed, and any disruption to the underwater ecosystem. Adjustments are made to the harvester's cutting blades or collection methods to ensure a sustainable and efficient harvest that preserves the delicate ocean environment. Asparagus harvesters, spearheading efficiency. Asparagus harvesting demands speed and precision to capture these delicate spears at their peak freshness. Asparagus harvesters utilize specialized cutting blades to sever the mature asparagus stalks just below the soil surface. Efficiency focuses on maximizing the yield of high-quality, tender asparagus while minimizing waste and damage to the developing shoots. Testing involves running the harvester through a designated asparagus bed. Data is collected on the number of asparagus spears harvested, the percentage of undamaged and tender spears, and any damage caused to the remaining shoots. Adjustments are made to the harvester's cutting depth and speed to ensure a swift and efficient harvest that preserves the quality of the asparagus for consumers. Date harvesters, reaching for peak dates. Dates, a delicacy enjoyed worldwide, require a harvester that can reach high into palm trees. These specialized machines utilize platforms or extendable arms equipped with shaking mechanisms or gentle grabbing tools. Efficiency focuses on maximizing the yield of ripe dates while minimizing fruit damage and ensuring worker safety. Testing involves running the harvester through a designated date palm grove. Data is collected on the number of dates harvested, the percentage of undamaged and ripe dates, and any damage caused to the trees or fruit during harvest. Adjustments are made to the harvester's platform height, shaking intensity, or grabbing mechanisms to ensure a safe and efficient harvest that preserves the quality of the dates. Seed cotton pickers, from field to fabric efficiency. Seed cotton pickers tackle the challenge of harvesting cotton bolls while preserving the valuable seeds used for planting future crops. These machines utilize specialized spindles or suction mechanisms to detach the bolls from the plant and separate the seeds from the lint, fibers. Efficiency revolves around maximizing the yield of high-quality cotton and seeds while minimizing loss and damage to either. Testing involves running the harvester through a designated cotton field. Data is collected on the amount of cotton and seeds harvested, the cleanliness of the lint separation, and any damage caused to the bolls or remaining plants. Adjustments are made to the harvester's picking mechanisms, suction power, and separation systems to ensure a clean and efficient harvest that optimizes both cotton fiber and seed yield. Sugarcane leaf harvesters, efficiency beyond the cane. Sugarcane leaves, once considered waste, are now a valuable resource for biofuel production. Sugarcane leaf harvesters navigate fields, cutting and collecting the leaves without affecting the sugarcane stalks themselves. Here, efficiency focuses on maximizing the amount of high-quality sugarcane leaves harvested while minimizing damage to the stalks and ensuring a clean cut. Testing involves running the harvester through a designated sugarcane plot. Data is collected on the amount of leaves harvested, the cleanliness of the cut, avoiding stalk damage, and any disruption caused to the remaining sugarcane plants. Adjustments are made to the harvester's cutting blades and collection mechanisms to ensure a precise and efficient harvest that maximizes the value of both sugarcane and its leaves. The testing process can be adapted to all kinds of harvesters, from fruit pickers to sugarcane harvesters. The core principles remain the same. Define what efficiency means for your specific harvester, speed, minimal waste, etc. Create a controlled testing environment, and then optimize settings based on collected data. Sharing these efficiency-boosting findings with your operators is key. After all, a well-tuned harvester is a happy and productive harvester. So there you have it. By putting harvesters through their paces and tweaking settings, we can unfold their full potential. This translates to bigger yields, less waste, and a more sustainable harvesting operation. Thanks for watching. If you like this video, thumbs up and subscribe to our channel. Stay tuned.